Thanks for coming to my talk. Appreciate it. I guess I should start with a disclaimer. I am not a Nix developer, so I have no skin in the game as far as Nix is concerned. I am just a user, and I guess Nix has been on my radar for about the last 2 years, and I've sort of got really into it in about the last year. So I have about a year of experience with Nix, developing Python environments with it. So this talk is aimed at people who have no idea really what Nix is. So that's the target audience for this talk. So the talk, basically what I'll do is I'll introduce like the state of the art right now in packaging and what my concerns are with it. And so I'm going to give a few examples of things that can go wrong with packaging. And then I'll introduce what Nix actually is, a very high-level overview of what Nix does. And then think about how you can use Nix. I'll have a little tutorial about the language. So it is a language and a package manager. And then throw in the sort of Python examples and little tips, tricks that can help you generate your own Nix expressions for Python environments, to make repeatable Python environments. And then at the end, I'll try and address where we are, like how Nix can be improved for Python users. Because right now, there are a lot of rough edges using Nix with Python. So first up, let's look at some of the concerns with the current system of packaging. I'm using Conda for these examples. I love Conda. Let's start there. The problem is not with Conda. It's sort of more with imperative installation as an idea, really. So first up, let's generate a new Conda environment. And it's Python 3.7. Let's install a package called SciPy. It's a package I use frequently, so I see this problem all the time. I use SciPy a lot in my work. And I install SciPy, but it takes me back to Python 2.7. This is what actually happens when I install SciPy using Conda. Just doing this. I know I could fix Python, all of that stuff. It takes me back to Python 2.7. OK, that's fine. It's one command. It did something. It changed the state of my system. It's supposed to do that in a way. So I deactivate the environment, fire up a new environment, Python 3.6. I install SciPy again, but it keeps me at Python 3.6. So what is that suggesting? Basically, it's sort of suggesting that the state of my system is influencing the outcome from that command. And that's kind of what a lot of this talk is about, how we can get around. This is what Nix does. It tries to get around this idea that the state of the system influences outcomes. So let's take another example like that. Conda install SciPy. SciPy is a package I use frequently. I get NumPy built against MKL, install SciPy. This time I'm fixing Python. I get NumPy built against MKL. That's fine. Let's do it in the reverse order. A new environment installs SciPy. I now have a NumPy built against OpenBLAS. I install SciPy, and I have a different outcome. So if I do the commands in a different order, I get a different outcome. I get a different version of NumPy. Same sort of nominal version, but it's built against a different version of BLAS. So that is an example of where state has influenced the outcome from commands. And that's what we're trying to avoid. Also, rollbacks. I have a new environment, 3.7. I install SciPy. I'm still at 3.7. I install SciPy. Oh, no, I've gone back to 2.7 again. That's really annoying. Remove SciPy. I haven't reverted to where I was. I would like to roll back to exactly the point where I was. I wasn't able to do that. And I want to reiterate, the reason I can do this is because Conda is really good. It gives me environments I can fire up and tear down. So it's easy for me to show these failures with Conda. I could do this with any other package manager, like Debian Package Manager, but it would be much harder to generate the examples. So this really, one of these problems, one of the most difficult problems is this sort of dreaded diamond dependency problem. I have an environment, I have two packages, packages. In this case, SciPy, SciPy, they both depend on NumPy, but they really want sort of different builds of NumPy. How do we resolve that? And it would be nice if I could have 2 versions of NumPy in my environment. Why not? I build with one, run with another. But you might not want to do that. So the questions we're asking: why isn't it safe to update my environment? Why do I have to worry when I do it? Why can't I roll back to a previous environment easily? Why can't I build with multiple versions of the same library? Why can't I have 2 versions of NumPy in my environment? Why is testing with different configurations so difficult? Why can't I test easily with different packages in a single environment? So in effect, we're sort of asking, why isn't package management more like what we understand about version control and what a lot of us are comfortable with? It is a much harder problem. That's to start with. So it's not that easy to make it like version control, but it would be nice if it was. So let's take a sort of high-level overview of what Nix is. So Nix primarily is a package manager. The package manager runs on different Linux distros. It runs on your Mac. It does not run on Windows. So there we are. There are sort of people that are trying to make that work, and people claim it works, but I'm not sure like where that is. It's certainly not something that you would want to try casually. So Nix also refers to the language about. Nix is a purely functional language, which means it's not an imperative language like Python. So when you refer to Nix, you could be referring to the package manager itself and the language that you use to write expressions in. Nix Packages is a collection of Nix package recipes that is on GitHub, and anyone can contribute to that. It's just a set of Nix expressions that tell Nix how to install packages. So that's primarily what we are interested in today. Nix is also a Linux distro, which uses those tools. It's not that popular. It's like, if you look at the Linux distro chart, it's like in the 40s somewhere. So it's not a particularly popular distro, but the package manager is probably way popular than the Linux distro. So there's lots of other Nix jargon and Nix things, sort of Nix deployment tools that you can use, which are kind of cool. I haven't used them an awful lot. I've used Cachix to share Nix builds with people, with your friends and things. And that's cool. It's a platform that does that. So how does Nix actually work? OK, so we have the Nix Package Manager. We have something called a Nix expression. You write the Nix expression, and the Nix Package Manager reads that Nix expression. So you write this purely functional expression that tells Nix how to take a set of dependencies from Nix package and produce some outcome that goes in the Nix store. So the Nix Package Manager can take stuff from the internet and from the file system. So in that sense, it has some impurity in it. It's nominally pure, but it has to have, obviously, some impurity. Otherwise, it wouldn't be able to do anything. So the Nix Package Manager instantiates a derivation. The derivation basically is a succinct form of that expression. It basically says, what do I need from the Nix store to generate this new package, essentially? Importantly, though, in this sort of cartoon of what Nix does, the Nix Package Manager does not care about the state of the Nix store when it's when it's generating that derivation or instantiating in Nix speak. So that's the sort of important part of this, is it doesn't care about what's in the Nix store when it's making this recipe. So the derivation is independent of the Nix store. So this is a dependency tree generated by Nix. So it's very easy to generate these dependency trees with Nix. It has that nice property. This is for NumPy 1.14. It's the one at the bottom there. So these are all its dependencies in Nix, right? So when you generate this, you get a sort of a list of its dependencies. And this is stored in the Nix store with this great big long hash as part of the path. So you can get some idea of how it's working now. So everything, that hash depends on the entire source of NumPy. It also depends on all the prerequisites or all the dependencies of NumPy as well. So there's a lot of stuff that goes into that hash. This is the hash or the path for G-Fortran. If anything changes in G-Fortran and this version of NumPy depends on that, then when it's rebuilt, it will have a different hash at that point. And this is, so one of the dependencies here is OpenBLAS. If we changed it to MKL, we would get a different hash. So we could have, in effect, two versions of NumPy in our store. That's which we couldn't have before. So Nix OS, a purely functional Linux distribution, is a nice paper by Dolster et al. It kind of lays out the rationale for Nix, and it's a really nice read, actually. I highly recommend it. Essentially, it lays out two things, that you have this purely functional language where you have no real impurity in it, and you have a purely functional data store. You can do packaging in a much better way and get around a lot of the issues we currently have with packaging. That's the claim in the paper. So you have this purely functional data structure that is entirely immutable. That's what I was showing previously on the last slide. So right now, this is a plot of the number of packages in given Linux distros against the number of fresh packages. And it's not very clear, but Nix OS is right up there, has a lot of packages and a lot of fresh packages compared with a lot of the other Linux distros. Now, why is that? One of the reasons is that a lot of the package-specific, the package manager's language-specific packages are getting put into the Nix repository, like from SciPy and gems and npm and all that stuff is getting put into the Nix repository because it's more easy, can be easily shared. Actually, so if you had everything from npm, you'd have more than, it's probably getting up to like 1 million packages in npm right now. And most of those are probably trash, so you wouldn't want those in your Linux distro, but yeah. So I'm just going to go over like a little Nix tutorial about the language, just so that as we move on in the talk, it's clearer about how Nix works. So I'm using the Nix REPL, which is the read, evaluate, print line tool for Nix. And Nix has integers. That's good. It also has floats. Floats, until I gave this talk, I didn't realize it actually had introduced floats. It didn't have floats in for a very long time. I've never seen a float being used in Nix. You don't really need floats for package management, but it's there. Nix has sets. Sets are really important in Nix. They're basically like Python dictionaries, but they're more lazy. So everything in Nix is lazy. That's an important sort of concept of Nix. So sets can be recursive. Because it's lazy, you can refer to other elements of the set. It's a nice property. Paths are first-class types in Nix, and that makes sense. Paths are important for package management, like in Python 3.7 now. Functions are basically like Lambda functions in Python, or like if you use CoffeeScript or something, or like in Haskell. It's very similar syntax to that, if you know those languages at all. And it's like the way you call a function is kind of reminiscent of other functional programming languages like Haskell. So everything is an expression in Nix. It's not imperative like in Python. That's sort of the important point about this. And everything is lazy as well. So Nix is nominally a pure language, but there is some impurity in it. You have to be able to read data from somewhere if you want to do packaging. So here I'm showing reading some data from a text file and showing that data. But if I write to a file, what happens? I can't just write to foo.txt. When I write to foo.txt, it puts it in the Nix store with a hash of the data in the file plus the file name. If I change that data, I get a new hash. It gets a new path. So everything in the Nix store has that quality to it. Basically, that's everything right there. You could start doing packaging just with what you've seen, in a sense, right? You can read, write files. You have to be able, unfortunately, there's something else you have to be able to do. You have to be able to build things, which is run something to do something. So to take data from files or from what's already there and make something new. And if we go back to our little diagram, the Nix Package Manager puts everything into what's called a derivation, the succinct form. And this is the simplest derivation you can possibly have. I'm doing this for demonstration purposes. First off, the first line here is reading in all the Nix packages that are available on my system, and then building this derivation. In the derivation, it's the simplest form. It says, what do I have to run to get from my dependencies to the outcome, what I want to put in the Nix store? And when I instantiate that derivation, it creates the derivation in the Nix store. So remember, the derivation depends on the system you're running on and the source that you're going to use to create your build, and a method to go from that source to the outcome. And this is basically a derivation in Nix. It's a JSON file. It says where is this going to go based on all the data that's coming in. It creates a hash. This is the path where you've got to put stuff. And it tells me what my inputs are, what my dependencies are. In this case, the only thing I depend on in Nix is bash, and then the platform, etc. So that's sort of introducing Nix a bit. Let's get into some Python examples. So you can do imperative installation with Nix. It's not all just one expression and you have some outcome. You can create environments like you do in Conda. It's a similar sort of thing. In Nix, they're called profiles. You can install, like here I'm installing hello, and then you have a function to create hello world. I can query the environment and see what I have installed, and I can list the generations of the environment. I've only installed one thing. I only have one generation. OK, let's install Python. I now have two things in my environment or my profile. I list generations. Now it tells me I have two generations of this environment. And with Nix, it's relatively easy to roll back from generation 2 to generation 1, simply with that command. And now I have two generations, but I'm actually at the first generation. So now if I query the environment, the only thing I have there is hello. So that's exactly the same as the generation of the environment that I was at before. So that's good. It does support imperative installation, but not so fast. It doesn't work for Python, unfortunately. So you can't do this. You can't install Python. Oh, I'll install NumPy. Oh, I'll install SciPy. No. That's how you would like it to work. That just doesn't work. So you need to use something called Nix shell for when you're using to install Python environments. So in that, you have to say all the things that you would like to install all at once, basically. You create one single sort of expression for doing that. And you can do that at the command line. You call Nix shell and list the packages that you'd like in your environment. And so what that does is it drops you into a shell with just those packages available. So the -- pure there creates a completely pure environment. So the only environment variables that you have are the ones that Nix gives you. So you don't even have $home. You don't have any of that. You don't know where your home directory is. It's crazy. So that's good when you're testing that you are only using Nix things. But sometimes you probably don't want to use -- pure because you'd like to be able to make a directory and stuff. Anyway, so you get a path, basically, like this, with everything that's on all the packages that you have in your, so this will like point to all the packages that are available in this environment. And you also get the way Nix works is that you also get, it puts everything on Python path, which some of you probably think that's a really silly idea, but that's the way it works right now. So Python path includes, just for this simple example, it's going to have like setup tools, SciPy, NumPy, but those are all, they're not in the base Python that you're using, not in the base Python site packages directory. So it's created new site packages directory for every single Python package that you want to install. So the reason for that is, if you think about it, if you wanted to put NumPy into your base Python site packages, you would have to change the hash of the Python path, and you can't do that. So that's the limitation with using Nix shell, with Nix for these sort of imperative installations. That sort of suggests imperative installation is bad, full stop. But I'm going to discuss maybe some ways around that for future at the end. So how do you create a script that will create a repeatable environment for you? So we did it at the command line, so we can put that into a script. So we can create our own Nix expression. We say, oh, let's use the Nix packages on our system. Let's use Python 3.6, and I want NumPy and SciPy environment. And this in my environment, and this expression does that for you. And you can call that with Nix shell, and it will drop you into a shell where you have those things available. Now, you can fix the version of Nix packages to what you want. And that will also fix the version of SciPy and NumPy that you're using. That's good. You don't have to keep fixing versions of things. You can fix a version of one thing, Nix packages, and that will give you the same version of everything else. And we'll get into that a bit more. So this is what this is doing. We're specifying Nix packages. If I say Nix packages equals something, it will use that version of Nix packages, and it will pull it from GitHub for you to a specific version. Now, it would be nice to put that version of Nix packages actually in the expression itself. And this is actually a Nix expression that does that. So this creates an expression in Nix that fixes the version of Nix packages. So you only fix all the versions you're using in one single place, which is nice. But that might not always work. You may want to use a different version of SciPy from the one in Nix packages, or a different version of NumPy, or whatever it is. Now, to do that, you can get fancy with the Nix language and start using the sort of the more difficult stuff, if you like, to build Python packages. So I'm showing here is a sort of a minimal expression to build SciPy 0.19, because for one of my projects, SciPy 1 does not work at all for some reason, and so I have to go back to an older version of SciPy, and this is a minimal expression in Nix to do that. So build Python package basically runs setup.py install or setup.py develop, and creates the Nix, the hash and all of that you need. And it does a lot behind the scenes to ensure that it's a reproducible build given the same inputs. It can fetch stuff from PyPy. So what it does, you put in the name and the version, and it gets that from PyPy. You've also got to give the SHA for that particular package. And with Nix derivations in general, you can specify build time dependencies, runtime dependencies, test time dependencies, and native dependencies, like if you're cross-compiling and stuff. Yeah, and it runs setup.py install. If this is the top-level package, it will run setup.py develop for you, so it's then in a development environment. So that you can write your own Nix expressions, but what is slightly easier is to use PyPy to Nix. So PyPy to Nix can take your requirements.txt and generate Nix expressions from that. So that's good for fast Nix expression generation, but it is a little complicated to debug. And it hardwires the version of Python as well, which is a bit of a pain. But what happens now with the latest version of Nix packages, you don't really have to worry so much that Nix packages is missing certain Python tools, certain Python packages, because it will actually install those on the fly when you run Nix shell in a temporary path for you. But that will go away when you close down the Nix shell. But it's kind of useful. It saves writing lots of Nix expressions for packages that aren't in the Nix packages. So what really sold me on using Nix was when I was using a mixed language environment. So I maintain a sort of web app that uses Python on the back end. It uses Jekyll, so it has Ruby gems, and it has Node packages and a lot going on. So there's it has Node packages doing testing of CoffeeScript stuff. So there's a lot of languages in that. And before I used Nix, sharing that with other developers was a nightmare. If you use Jekyll and you share it, it never works if you change a version of one of the plugins, it breaks. And so you need a new version of it. It's a terrible situation. And so this really helped with that. It really kind of fixed down the environment for me in a really good way. And what's also nice is that you can deploy the same environment on a CI that you actually use for your development. That's really good as well. And this environment was extremely difficult to maintain without Nix beforehand. So you can use pip with Nix. So you can cheat a bit. Nix is supposed to be pure, but you can do a little bit of cheating. You can use a temporary approach. So Nix gives you a temp path, and you can pip install stuff into a temp path. That will go away when you close down your Nix shell. You have to have pip in your build inputs. Another thing you can do is a more permanent approach is to actually set up a .local in the directory where you're working, and then you can pip install with --user. You can pip install stuff locally, and that's a permanent approach, but highly impure. It sort of breaks the Nix paradigm. Nix is great on Travis CI. Travis CI supports Nix, makes it really easy. You can cache. It's easy to cache the environment. Nix is really set up well to do caching of builds. That works really well. But the most important thing is that, once you have your environment on your development environment, you can use that same environment for testing. You don't have to write, I use this same Travis.yaml for every project I work on. I don't need to change anything in it. So you don't have to have your specific development environment and your testing, all of this stuff. It makes it really easy. So just to go over a few things, my Nix frustrations, you can't move the Nix store and use Nix effectively. That's really annoying. Disk space can be large. I use 47, I just checked it, 47 gigs is devoted to my Nix store on here at the moment. That's a lot on this laptop. It does have a steep learning curve because you're learning a different programming paradigm, and the documentation is bad. Let's just be honest. It's basically going through people's blogs and just all of that sort of stuff. And I learn more from going through Git issues and pull requests than I do from reading the documentation. So. And you can't install Python imperatively. Doesn't stop me using it for Python, but I think that would be a stumbling block for a lot of people. And there's extreme pressure on Nix packages right now from all of the sort of language-specific distributions. It would be great if Nix worked imperatively with Python. And how would that could work? It's possible. You could change the hash of the main Python directory every time something's installed, so you'd copy it and make another copy. There's ways that could work, it just hasn't been implemented. It would be good if Nix packages had multiple versions of like NumPy, so you didn't have to kind of rewrite your own scripts to install NumPy and SciPy, things like that. So the major packages. Nix works great with Haskell. One of the reasons for that is that you can just do call package and then the name of the package. So you don't need like a specific Nix package recipe in Nix packages for Pandoc. You just do that, basically. And one of the reasons for that is that Haskell packages have a declarative standard for their packaging, and Python really doesn't. So Python, you have to run setup.py to know how to install something, if you like. And there's setup.cfg, there's all these things that you have to know about in order to get a package installed. And so you have to actually run Python to install something, to know how to install it, which is unfortunate. So whether that could ever be fixed, I have no idea. I'm not like deep enough into that community to know. And just having a community of users. So if people are interested, please speak to me about this. And I'd like to, like if you want to get into it at all and you just want to discuss it, I'd love to do that. Okay, thanks.
We're up against the break, but we can take questions if people want to file out. I'll let you pick.
I have two questions. One was, it's not helping you with any dependency resolution, is it, with the Python packages?
The question was, does it help with dependency resolution with Python packages? I think it does. I mean, that's the whole point of Nix, right?
Well, I don't see anywhere where you're specifying the, like, you know, with a Conda package, you'll specify what a package consent or requirements associated.
Right, so in the example I had, the environment depended on two packages, NumPy and SciPy. They have their own builds, which depend on other things. So it effectively does that.
It's possible I made obtuse and I missed something, but I fail to see, in theory this looks really cool, but I fail to see how in practice this is better than Singularity or Docker for managing the problems that you have.
So this doesn't fill the same space as Singularity and Docker. So the question is this worse or better or different from Docker? And really, this fills a different space. Typically, you would use this inside a Docker container. So you'd install Nix inside your Docker container. In some ways, it overlaps in that the sort of build language is a bit like the build language of Docker. However, Docker is not pure in the sense you build your Docker container, you won't necessarily get the same result in a year's time.
But if you cache the images, you do.
If you cache the...
It solves that problem as well.
Right, but say you have the raw language, if you run that, you won't necessarily have the same result. Unless you pin versions and use hashes and things like that, you have no guarantee that you're getting the same build. And this it's inbuilt into this that you get the same result, regardless of what happens. So yeah, they do overlap, yeah, I think you're right.